Yeah, in continuation to previous video, when we execute this program here, we are trying to print the numbers in sorted order before writing the actual logic. Okay, so let us just look at to whether numbers are printed in sorted order or not. Okay, so here it is asking the input. Okay, so same 12 is the number of elements, n value. Okay, so this 12 first scanf reads and stores into n. Okay, so then 12 numbers here it is expecting. Okay, so what are the 12 numbers here? These are the 12 numbers it is expecting here. Okay, so those numbers will pass as a argument here. Yeah, I think there is a mismatch with the numbers I copy pasted once again. Okay, so let me just enter some 5 numbers. Okay, so randomly I enter some 5 numbers, 2, 5, 1, 6. Okay, again some 5 duplicate numbers I am entering. Now you can see here 2, 5, 1, 6 minus 95. Okay, so there is some problem with the Q sorter function. It is not sorted. Okay, so we need to look into this compare function void star a. Okay, so here they are constant pointers. Okay, so you write them as constant. Okay, so that's why we are getting some error here. Format percentage d expects argument of type int star, but argument 2 has, what is the argument 2? Let's type char star. Where it is char star? That's why we are getting wrong output here. Scanf percentage d address of a of I. Sorry, I have declared a as character type. Sorry, this is integer type. That's why all these numbers are printed as characters. Okay, so our array should be integer array. Integer numbers we are going to store now. Okay, right. So once again we run these kind of errors. Initially, if you rectify, then immediately you can overcome such problems. So 5 I enter here. Some numbers I am entering randomly. Now see here 2, 3, 2, 4, 4. Okay, so still there is some problem with compare function 2, 3, 2, 2, 3, 4, 4 we should get actually. Okay, so that means this compare function definition we need to look into. Okay, so it is say CMP FUNC. So I write like this. Then what is happening? I is equal 0. After A is our array, no? Right? So size of int. Okay, then. Right. So yes. Okay. Yeah. So return type void we have kept here. Okay. And we are returning some, and return type we have kept as a void. Okay. So here it should be int. Okay. So it is returning some integer number, no? Right. So these kind of now you can see here there is no warning also. Okay, so now you get correct outputs. So 5 number of elements, and randomly I enter some numbers. Okay, so even duplicates I enter. Let us just check out whether they are now you can see 2, 2, 3, 3, 4. Your numbers are in sorted order. Your numbers are in a sorted order. Okay, so that means this function is working fine. Once you get these sorted numbers, that means this is how the sorted numbers are. Okay, this is our sorted numbers. Assume these numbers are in sorted order. Then you can implement this logic. You can implement this logic, and immediately it takes hardly 5 minutes to code this. Okay, so you should not get panic with these type of errors during your examinations. Okay, so for that purpose, I deliberately introduced some errors in the program. During examination also, you should not get panic, and with cool minded, you should rectify all such errors. Okay, right. So this is not part of our code actually. So I am just removing this. We don't want this. Actually, this we want at the end. No? Okay, so right. So numbers are in sorted order. We got here. So what is our logic? What logic we developed? We need a variable called as unique, which stores unique numbers, distinct numbers in the array. Okay, so that's why I'm declaring a variable here, unique here. So int unique or distinct, any variable name you can choose here. Int unique is equal to say a of 0. Directly the first element I am taking as unique. Okay, similarly we require one more array, no, one more array here, resultant array. Okay, so I say result of size n. Two arrays I am declaring here. Okay, so I got one unique array. Similarly, to keep track of the second array, we require a variable called as a j here. Okay, and initialize it to 0, because in second array you need to store starting from 0th index onwards. Yes or no? Okay, so that I am catching in a variable called as a j is equal to 0 here. Okay, right. So now see here, I got a unique element. A of 0 is the unique element. This first element is the unique element. Obviously, this is the unique element. Okay, so immediately I store that into resultant array. Okay, so I say result of j is equal to unique. Okay, so that means the first number will be stored in a result array. Okay, so here it will be stored here. This first number will be stored in the result array. So afterwards, next number should go to next position. So that means you need to increment the j value, you need to increment here. Okay, so that means instead of writing separate statement, you can just write inside the array index itself, result of j plus plus. This is post increment. First result of j will be executed and unique value will be stored. Afterwards, j value will increment. Okay, so no need of keeping track of j value separately here. If you write like this, then it is well and good. Okay, so the first element will be stored in a result array. Okay, we got the first element into the result array. This one we got. Okay, so from index 1 onwards, we need to store remaining elements, and here also from 1 onwards, we need to find out only distinct elements. Okay, so this is the loop we need to implement. Yes or no? Okay, so the same code will write here. So I'm using a for loop here for storing distinct numbers. Okay, so here you can write the comment. In examination not required, only for your understanding I'm writing here. Okay, so find out distinct elements from the array, or you can say from the sorted array, because already your array is sorted. Okay, and store in result array. Okay, so if you write such a comment, afterwards you can understand what for you have written this for loop. Okay, now I say int I is equals to 1 from next element onwards. Okay, so then I less than n, then say I plus plus. Okay, so what logic we need to implement? That means first element onwards we need to compare. Okay, so that means whether this element is not equal to this first element. If not equal, then this will become the unique element. This will become the unique element. That is what we have done here. Here, this logic. Okay, so the same code will write here. So if where is the first element? In a of I, in a of I position, a of I not equals to, instead of checking equals to, better you check not equals to, so that it confirms that is a unique element. If a of I is not equals to unique, a of I is not equals to unique. Okay, so that means it is a different element. It is a different element. In unique, we have stored 1. As per our example, you have stored 1 in unique. Okay, then you are checking the next element. Okay, so in sorted array, you are checking the next element, this one. Is it not equal to this? If not equal, you can say that this is the unique element. Okay. So then what you do, you store into this variable. We have written the code like this here. Unique is equal to A of I will become the unique here. Okay. So then I say that unique is A of I. Unique is equals to A of I. A of I will become the unique. Okay. Now you got the unique element. No, immediately you store into result array. Then I copying into result array. I say result of J plus plus. Result of J plus plus is equal to unique. I'm immediately copying this unique array into result array. Unique element into result array. That's it. Okay. So what happens here? Now, if we keep track of our array here, now A of I is 2. 2 not equals to 1. Now you can see here. Okay. So I'm just writing here in unique 1 is there. Okay. Then next A of 1 is 2. Okay. So 2 not equals to 1. Yes. Okay. So then in this unique memory location, 2 will be stored. That means I got a unique element. So then I am copying this into here. That is what this logic is. Unique is A of I. A of I will become the unique, and that I am copying into result array. Okay. So then end of the loop reaches, automatic control goes to I plus plus. I value will become 2 here. I value becomes 2. Okay. Then see here in 2, we have the number 2. Now it checks. A of 2 not equals to unique. In unique, what is there? 2. A of 2 contains what? 2. 2 not equals to 2, false. Then what happens? Nothing will be executed here. End of the loop reaches, automatically control goes to I plus plus. I value will become 3 here. So in 3, what is there? Just see here. This is 0, 1, 2, and 3. In 3, we have the number 3 here. Okay. So how it is executed? Now you can see here. So 3 less than 12. Yes. Now A of 3 not equals to unique. A of 3 is what? 3. Okay. What is there in unique? 2 is there. So 3 not equals to unique? Yes. 3 not equals to unique? Yes. Okay. So if yes, what we are doing? Immediately we are storing that A of 3 into the variable unique. Okay. So that means now the unique contains the number 3. The unique contains the number 3 here. Okay. So then this I am copying into this array. That is the code here. Then result of J plus plus is equal to unique. That is copied into this unique array. That is copied into result array. 3 is copied here. Okay. So then what happens? I plus plus. I value becomes 4. Okay. So in position 4, what is there? Just see here. Another 3 is there. Okay. So what happens here? A of I not equals to unit, false. So I plus plus. I value increments. So it goes to next one. Okay. This 4. 4 not equal to 3. Yes. Then unique contains now 4, and this will be copied into result array. These are the two elements. If condition becomes true here, and these two will be executed. Okay. So like this, one by one element, only distinct elements will be copied into this result array. Okay. So once your for loop ends, when your for loop ends, I less than n, I less than n. Okay. So that means until it goes to the last elements. Once it completes the last element, I value increments, I value becomes 12, 12 less than 12, false, comes out. Okay. So when this loop terminates, what is happening as per our diagram? This result array contains only distinct elements. Only distinct elements will present in this result array. Okay. So now we need to print this result array. But we have declared a result array of size n. Of size 12 we declared. But how many elements are there in this result array? That we should identify. Okay. So how we can identify here? That means we are keeping track of J value here. We are keeping track of J plus plus we are saying here. Okay. So once you come out from this, the final value of J is nothing but the number of elements into the second array. This gives number of elements into second array. Okay. So gives number of distinct elements. Okay. So number of distinct elements, how many there? That is indicated by this J here. Okay. So what you need to do, you should, n always indicates number of elements. No, now you say n is equal to J here. N is equal to J. The second array contains now n elements, n distinct elements you can say here. Okay, right. So now you print the distinct elements from the array. Okay, so but here this time you should write result of I. What is where are the distinct elements? Distinct elements are present in the second array result. This array you should print. Okay, so that's why when you write here, see here, printf percentage 4d comma result of I. Now you will get only distinct elements in sorted order, right? So this is how you can implement. Hardly it takes 5 minutes. Okay, most of the time you spend in understanding the logic and generating the logic on paper. Once you get the logic on paper, immediately you can write corresponding statements easily. It takes hardly 5 to 10 minutes. Don't worry. Right, let us execute this code. Let us see whether now see it is asking nothing is visible. See, generally when we write a printf enter n value, that statement is appearing here, but in our online examination we should not write that. So this scanf is executed. Now it is expecting the first line. So what is the first line? 12 is our first line. I am now entering the same input here. With some patience, I will enter all the numbers. 12 is the input. Okay, so what are the 12 numbers? 14365. 14365. In online examination, you not required to enter these things. Once you compile and run your code, automatically your program reads input from backend. Okay, so already test cases are available, stored in files. Okay, so your online environment is designed in such a way that your code automatically reads from each file one by one and executes. There are 10 test cases, means your program will be executed behind the scenes 10 times. For each test case, your program will be executed. You are not knowing all these things. Okay, so on the screen, it is appearing test case 1 success, test case 2 success, test case 3 success, test case 4 failed. Such kind of messages you will get. Okay, right. But during practice, you should do practice in this way. Okay, so input and output you should check manually on your own. But code is same. The same code, if you execute in online platform, it works. Okay, so it reads automatically from their files. Okay, 14365, then 23545. Okay, so 23545, then 42. Okay, so last two numbers are same. You should give space 4 and 2. Now I enter. Now you can see 1, 2, 3, 4, 5, 6. Only distinct elements, non-redundant elements in sorted order, they are printed. And please remember, you should not print any extra or comma while printing the numbers, because your output, expected output, should match with the actual output. Okay, in their actual output, if it is given 1 space, 2 space like this, and if you provide a comma here, generally people what they do is they write like this %d comma. Okay, and when you execute this code, what happens? Just I enter 5 numbers randomly. Okay, so 2, 4, 2, 1, 3, I enter. Now this is how it is displayed: 1, 2, 3, 4, which is not as per the actual output. Your expected output, actual output not matching. Then you will see test case failed. When expected output and actual output both are matching, then it says test case passed. Success you will get. Okay, so while printing the output, don't put any extra commas or even a full stop at the end. Nothing. You should, as per the given format, you should print the output. Okay, so here for our clarity, I'm just using %4d. Okay, or 2d, 3d you can use, so that you can get space between these numbers. Okay, right, you can just see here, say 2, 4, 3, 1, 3, I enter. Now you can see 1, 2, 3, 4 in sorted order printed. This is how we need to develop the logic and write the code. Don't get panic, don't get angry. Okay, so with cool minded, you try to write the code, try to correct all errors. Even even none of your test cases are satisfied, but if your code is still compiled without any errors, there is a chance. Yeah, got okay, right. So we'll stop here.